Welcome, nerds and brainiacs, to the second ever video of this YouTube channel. It is a pleasure to have you today to be speaking about like-term algebra, which is an important part for learning algebra, as most of you may know. How most people may think it's just know it's important. It's always important. You'll be learning about it right now, of course. And before I start, I think I'll have to point out a few things. First things first, probably you have been taught this in school, and just in case you have, probably skip the video but a little bit. But I'm just writing an equation. 5x plus, let's say 6 is equal to, and let's just leave it like that. I just try to explain what this is all about. So this number here, this is called a constant. So I probably should write that. So this is a constant, which is this. Yep, constant right there. It's a constant. Looking at it this side, oh, my fault. On this side, this is a coefficient, you could say. It is actually called a coefficient, just so you know. So a coefficient, which is usually a number in front of the variable. Now the variable in this case would be our x. Now there's no need for you to remember all this, but I just thought it might be important for some people, because some tests may be talking about these things. So yeah, it's all up to you if you want to learn about it or not. I just left thought of speaking about it. So there's your variable, x is a variable. Your 6, that's a 6, that's a weird 6 that I made there, but yeah, it still counts as a 6, so that's a constant. Your 5, which is the number in front of the variable, your x or your y or your z or something, any other number, any other variable, that's your coefficient in front. Whichever number is in front of the variable is a coefficient. Yep. So yeah, that's all I need to say, because most people might find it hard. So yep, let's see. I'll take it all out now, and let's start with our first equation of the day, which is gonna be about simple like-term algebra. And we'll start with the pluses. We'll start with the addition, I guess. That's an 8 plus 8 plus 5y plus 3. So today we won't be solving much of an equation. We'll just be finding the like terms. So what I mean by like terms are these things: coefficients and a constant, which are similar to another coefficient and a constant. So this coefficient and a constant is similar to this coefficient and a constant, right? Sorry, not a constant, sorry. Coefficient and a variable, my fault. I guess, yeah, just error there by my part. So you group those two together. So you could even use brackets if you want. Probably it would be better if you use brackets, because brackets usually mean that you do these first. So 3y plus 5y and then add, and then and then you bring these two together, because they are like terms. So like terms basically means same thing or similar. So yeah, it shouldn't be similar, it should be the exact same thing basically. So like the numerals are just by themselves, the constants are by themselves. You just group up all the constants in any equation, and yeah, there you have it. 3y plus 5y, that, and we'll just put a plus sign there, because we know that's a positive, and we won't be, yeah. I'll explain that later in some other video, but it is important to have a plus sign there, and you can't end your answer here. This is just you using, this is just you guys doing your equation. So you do 3 plus 5. You wouldn't really do anything with the y's because they're the same, which is why we're grouping them together. So the y's, they stay the same throughout. Let me just show you. The y's do not change. So the answer is 8y. 3 plus 5 is 8. So yeah, the y's stay the same throughout the whole thing when you do a like term algebra equation. Yeah, the only thing that really changes in this is the numbers, not the y, not any other a variable. Yeah, not any other variable. The variables do not change in this. And then you add a plus onto here. 8 plus 3 is 11. Sorry for my horrible writing again. It's just been bad lately, not gonna lie. Holy, what is this? Okay, yeah, so if you got this answer, you got it correct. Good job, guys. I probably forgot to mention that if you want, you guys could even continue with these questions yourselves. It's all fine. Hey, let's just see. Now, next one we're going to do now is subtracting, like term algebra for subtracting. So this is one of the questions I have prepared for you. 5y minus 3 minus 2y. Okay, my writing might be not the best right now. Oh, that's supposed to be a 1. Might have to redraw that. Yeah, okay. Holy, why's my 1 not being the best? Okay, that's fine. Yep. 5y minus 3 minus 2y minus 1. So the same thing we did last time. The first thing we did last time was find the like terms, and that's what we'll also do for a subtracting one, which is where we just basically minus it instead of plussing. It's not that hard. You just bring the like terms together. So this is one of your like terms because it has a y. This is one of your like terms because it has a y. And these are also your like terms because these are constants. Constants are always like terms. Also, may I need to add one more thing. The minus sign also goes with the coefficient and the variable. Every single thing, the minus sign goes with them. Same for this positive sign that's in front of here, right? So that's a plus 5y. So it'll be 5y. This time I won't use the brackets just to show. 5y minus 2y, and then negative 3 minus 1. I'll use my 1 like that now. Let's see. 5y minus 2y. So we do this first, then we do this. Oh, wait, my fault. Let me just take that out. Do that, then we do that. Okay. Do that, and then we do this side. So do this side first. 5y minus 2y. This should be equal to 3y. Oh, my fault. It's equal to 3y. Negative 3 minus 1. Now, some people may need to use the calculator, but basically what it's saying is negative 3, you take out 1 from that and you get negative 4, which is simple and easy. That's how I understand it. Some people may understand it differently. It's all fine. But 3y minus 4 is your like term algebra, I guess, equation. That's how you find your like term equation. Yep. Now continuing on, we're going to a little bit more complex one. Let's say we mixed up the addition and the subtraction, right? Let's say we mixed those two up. We'll mix those two up. Just a second here. Yep. So this is positive, right? This is also positive. Oh my, that's a weird positive, but okay. Positive 8, okay. Let's see, -2. And then negative, let's say 6. Yep. I didn't want to make it too hard, so yeah. Positive 10. That's a positive 10 with a plus sign at the front. So we bring that. Since it has a y on it, we're bringing that. And since this also has a y, we're bringing that with the 10. It's gonna come with the 10. So that will be 10 y minus 2y, and the next one is a positive 8 minus 6. Now the reason I may think that it's tricky for some people is because I don't know, but some of my friends, I guess, they have problem with these type of questions. So I just hope you understand. It's a simple mistake. Some people just forget the plus sign, some people forget the minus sign, and some of the times when it's mixed up, people just forget entirely what happens. So yeah, it's fine. Everyone makes mistakes. If you do, just know, take your time, do your assessment well. It's all gonna be well. So 10y minus 2y is equal to 8y, which is the answer I wrote. Next, positive 8 minus 6. Positive 8 minus 6 is equal to positive 2, right? That's your answer. So if you got this, you're correct. Good job, correctamundo. Continuing on. Now, next thing I'd really want to teach you guys is something that might confuse most people, but I think it's better to teach it right now than not later. So, one thing is to confirm y is not, y is not equal to y to the power of 2. It's not equal to, it's not the same. These are totally different. They are not the same, right? These two, they're totally different. So this one, y to the power of 2, is actually equal to y times y, right? So it's y times y. But y, on the other hand, I'm saying a lot of y these days, but y, on the other hand, it's a little bit complicated about y. It's just y. Y is just y. You don't have any power, but y actually has a power though. You have y to the power of 1, which basically means y, just y. So yeah, this is just equal to y. This one is equal to this, which is, yep, this one right here is equal to that. The y to the power of 2 is equal to y times y. So these are totally different. Same for any other ones. Let's say there's y1 and there's a y to the power of 3. They are not the same, right? They're not the same. This one is equal to y times y times y, while this is equal to just y. This one right here, right? They're not the same. They're never the same. Not even close. So remember that they are not the same. Let me just make a note here, maybe. Not. Holy, my handwriting needs to improve too here. Not same, yeah. Yeah, let's just leave it like that. So they're not the same. Y to the power of anything is not equal to y to the power of let's say 1, y to the power of 1 is not equal to anything like y to the power of 2 or 3 or 4 or 5. If it's y to the power of 1 is equal to y to the power of 1, then it is correct. It is very much correct. But you just can't use it even in addition or subtraction. I'll show you an example, right? Let's do 3y plus 5y squared plus 6y plus 4y squared, right? So although this has a this has a variable, it's not the same thing as y. So this thing is only similar to this value right here, and that means that it's not equal to this, not that, and not that, because it has y to the power of 2. If it had just y, it would be similar, just like this, just like this one, just like this one. They're similar. Now you group these two together. 3y plus 6y is equal to 9y. And if you got that, that's correct. Oh, sorry, no, my fault. I just realized what I just did. Let's forget about that. Oh my days, I forgot about this part. Not my fault. You'll also have to do this part. So you group these two together, because unlike the y, they may not be similar to the y, but they have the same variable as each other. So you'll just use these two, same variable. So yeah, it'll be plus 5y squared plus 4y squared 9y plus 9y squared. So if you got this as your answer, that's correct. Yeah, so if you got that as your answer, that's correct, because 3 plus 6 is 9, and 5 plus 4 is 9 too. So yeah, correct. If you got that, pats on the back. Congrats, I guess. Continuing on, let's go into probably a little bit harder one. Let's go into how about times? Let's go into times now, for like terms. Yep. Let's see times. I want to look into dividing, but let's go into times. Actually, it might be a little bit more easier and help you to understand. So for times, we're not really looking for a like term. So if it's 5x, sorry, I'm very good at drawing y's, I think. If it's 5y, right, and another variable has like a 5x onto it, which is times 5x, you would realistically not do anything in the like term part here that I'm covering. You won't be finding anything in the like term. You won't be looking at the y's, you won't be looking at the x's. I probably should do that in another colored pen. You won't be looking at the x's, you won't be looking at the y's. You basically, in multiplication, it's very common here, you just directly multiply. So you directly multiply the numerals first, right? First the numerals. So 5 times 5 is equal to 25. Sorry for the weird 2 there, but to bear with me. 25. And what do you do next is, right, instead, you know how you can write xy. There's a way you can write xy. So what that basically means is that there's a times sign here. There's a secret dot, I guess. Secret dot. Just place it with maybe a red marker. And then there's like a times sign here. That times sign basically symbolizes that it's being multiplied there. So you could also write on here the same thing. Put it here. X, Y. Now usually it doesn't matter if you put the Y or the X first, but it's better for you in maths if you put like in alphabetical order, right? Like A first, then B, then C, then D. Like it's better that way. It looks much more cleaner. It looks much more better, and probably is a marking criteria in most countries. You might realize that as you go up a level or two. So it's better if you just put 25xy instead of 25yx. Both work, but it's even better if you just do 25xy. If you know, the more you know, the more better. Yeah, so that's amazing, guys. If you guys learned that, I don't know if there's any need of continuing on this topic, because realistically that's all you need to know for the multiplication side. Now dividing side might be a little bit more complicated on the like term part. So let's see on the dividing side. Right. So I have 25x, and let's say it's x to the power, no, 25x, and then someone has 5x. Now, I don't know if this is really like term. I don't know what I would say what it is, but it's the closest thing to like terms. So you're gonna be looking at the 25, the numeral, and the numerals first, so the 25 and the 5. See if it's divisible. If it's not, then just leave that and go on to the x's and check if that's divisible. If it's not, then leave that and just probably look some other way, probably dividing it by 2, dividing by 3, anything. But here you can see you can divide this by 5 and divide this by 5. I guess it's not dividing by 5, but it's more like timesing by 5. No, it's actually dividing by 5. My fault. Yeah, it's actually dividing by 5. 5. And then here it becomes a 1. At the bottom it becomes a 1. But we don't really want to know about that. So it's 5x. Okay, my fault. So it'll be 5x to the power of x. Now I guess this is more of equations now, but it's better if you know more, right? So you can also take out these x's since they are same constants, same variables. So you take out that x, let me do it with a red, take out that x, take out that x, you get 5. So if you got 5, your answer is correct. Pat on the back, amazing job. Basically got most of the topic on this right. There's another one that I probably have to explain where where the x has a power on it. So let's say the same equation, let's use the same equation as last one, but let's add a power. Okay, let's add a power to these x's, and I'll add the power of 3 onto this, and then I'll add x to the power of 2 onto this. So let's see, 25x to the power of 3 is equal to, so as you know, you just divide this by 5. Again, divided by 5, right? Since you're gonna be doing that, the numerals first, you're gonna be doing the numerals first. Do the numerals first, then you divide this by 5. Then you get 1 at the bottom here, but 1 is non-existent, so you don't really write it anywhere. Yep. So all will be left from that is x to the power of 2 and x to the power of 3. Now let's go a step further here. We can go a step further because, as we know, as I've probably taught you guys, how y to the power of 2 is just y times y, then x to the power of 2 is x times x, right? Then 5x times x. Oh my, this is gonna take so long. My fault, okay? Drawing part definitely takes the longest in this. The explanations could take 1 minute, for God's sake, and I'm here doing all this now. Going back onto this, what we can do here, right, gang? What we can do here? Take off the excess, take it off completely. We can remove it. So we can remove this x here because we have an x here too. Then we can also take out this x here because we have an x here too. Now forget about these times sign because they will not exist anymore. Remove this one too, I guess, if you want. Actually, nah, keep that x because times sign, because you'll actually need that. So keep that times sign there. I might as well just remove that. Yeah, keep that times sign because then it'll be inaccurate. And then your answer should be 5 times x, which is also known as 5x. So basically, when you're dividing with a power, you're going to be subtracting it, right? You're going to be subtracting it. You're not going to be adding it or anything. Now, I guess I forgot another main part which I should actually teach right now. So let's just go back onto that. This one's about multiplication with powers, where you multiply with powers, which shouldn't be that hard since you guys already did dividing with powers. It's not the hardest in the world. Definitely most people can do it, no problem. It's probably the easiest topics in the world, these ones. It only gets harder when you get into like 12 or 13 levels. Yeah, 12 and 13, that's crazy. Yep, going back onto the topic. Let's see, I have 5x to the power of 2 times 5x to the power of 3. These powers would actually, instead of being minus, would be added together. Yeah, so instead of 2 and 3, it'll become x to the power of 5, because 2 plus 3 is equal to 5. You get it from these ones here. Okay, just to make sure. 2, yeah, and 3. You basically put the 2 here, right? Put the 2 here, and the times here, and this is your 5 here, which comes from here. Yeah, it's not that hard. I'll actually have to go back in the video and check if I made an error. I think if I did, I'm extremely sorry. Did I? I might have made a video error, but if you guys enjoyed this video and think it was helpful, then thank you very much. Oh wait, before I end this, I should also probably explain what if it does not have, like, you know, what if it's just like 5x times 5x. Well, as we know, 5 times 5 is 25. It's not that crazy or anything, but an x has always the power of 1 with it, even unless it's written some other numeral, it's always carrying the power of 1. So x is equal to x to the power this is where you get that from. This is where you get that from. It's sorry if I'm speaking quite lowly right now. It's just that I have to maintain my silence. Yep. Hope you guys enjoyed this, and since it's quite late at night, I probably should end